Good morning to all. Welcome to physics class. Myself Mamta. Today I am going to discuss on the topic thermodynamics. In that expression for efficiency of Otto engine. Now let us, in order to derive the expression for efficiency of Otto engine, consider 1 gram of the working substance and is taken in the Otto cycle. So let T1, T2, T3 and T4 be the temperatures of the working substance at the points A, B, C and D respectively, as indicated in the PV diagram. So that is, at the points A, B, C, D, temperatures are T1, T2, T3, T4 respectively. So let Q1 be the amount of heat absorbed by the engine during ignition stage, that is from B to C as indicated in PV diagram, at constant volume. Then the amount of heat absorbed is given by the expression Q1 equals mCV dt is equal to, since we have considered 1 gram of the working substance, so m will be equal to 1. So we have 1 into Cv T3 minus T2, call that equation 1. Where in that expression m is the mass of the working substance and Cv specific heat of a substance at constant volume. So let Q2 be the amount of heat rejected by the engine from D to A as indicated in the PV diagram at constant volume. Then the expression for Q2 is given by Q2 equals 1 into Cv into T4 minus T1. Call that equation 2. So now let us divide equation 2 by 1. We get Q2 divided by Q1 will be equal to T4 minus T1 divided by T3 minus T1. Call that equation 3. So from the definition of efficiency, we have efficiency eta is given by eta equals Q1 minus Q2 divided by Q1, or eta equals 1 minus Q2 divided by Q1. So now substitute for Q2 by Q1, we get eta equals 1 minus T4 minus T1 divided by T3 minus T2. Call that equation 4. So now from PV diagram we know that points C and D lie on the same adiabatic. Then we can write T3 V1 to the power of gamma minus 1 equals T4 V2 to the power of gamma minus 1. Or rearranging that, we get T4 V2 gamma minus 1 equals T3 V1 gamma minus 1. Call that equation 5, where gamma equals Cp divided by Cv. Similarly, the points A and B lie on the same adiabatic. Therefore, we have T1 V2 to the power of gamma minus 1 will be equal to T2 V1 to the power of gamma minus 1. Call that equation 6. Now subtracting equation 6 from 5, we get T4 minus T1 into V2 to the power of gamma minus 1 equals T3 minus T2 into V1 to the power of gamma minus 1. Or T4 minus T1 divided by T3 minus T2 equals V1 divided by V2 whole to the power of gamma minus 1. Call that equation 7. So now substituting equation 7 in equation 4, we get the expression for efficiency. So therefore eta equals 1 minus V2 divided by V1 divided by V2 to the power of gamma minus 1 equals 1 minus, now take V1 to the denominator, we get 1 divided by V2 by V1 whole to the power of gamma minus 1. Or eta equals 1 minus 1 over rho whole to the power of gamma minus 1, where gamma equals V2 divided by V1 is called compression ratio. So this is the expression for efficiency. Thank you.